In this video, we'll continue our discussion of derivatives of vector-valued functions, finding some tangent lines, tangent vectors. So sketch the vector value function. There are multiple steps to this, so I'm going to label. This is one, sketch the vector value function, find the point of tangency, and then find the tangent vector at B. All right, so number one. All right, sketching the vector. Remember, we have to find a way to relate them. So I have x of t and I have y of t. So in my sketch, I'm going to do, okay, x of t is equal to 3 cosine t, and y of t is equal to negative 2 sine of t. So I can solve now. I know that x over 3 is equal to cosine. I don't need to write of t there. We know what the variable is. And then also here, y of negative y of 2 equals sine of t. I can plug these into my Pythagorean theorem, Pythagorean identity meaning. So plugging those in, I got x to the third over 9 plus y squared. I put a 3 there and it should be a square. I don't know why I think I was looking at the 3 in my head. 2 squared is 4. So this gets me an ellipse. So let's go ahead and graph that with a dotted line. Do it in a different color so we're not black on black. Each black tick mark will be 1. So in the x direction, I know the ellipse is sitting at 3 in each point on the axes. And then in the y direction, I have 2's. Well, we should probably label, since we flip these things so much, we should label our axes every time. Right, I'm going to take a dotted line now and make my ellipse. Oops. Let's do one section at a time. There we go. There's my ellipse. I think it's good enough. Okay, so we need to figure out where this thing starts so we can graph the curve appropriately. So we're going to do r of 0. So it's t equals 0. Gets me r of 0. If I plug in 0 for both of those, okay, so we get cosine of 0 is 1. So I got 3 comma sine of 0 is 0. So my first point I know is at 3, 0 right here. Let's get another value. I'm going to do something that's going to work out nicely. So I'm going to do pi over 2. I put a 0, but I meant pi over 2. Okay. Cosine of pi over 2 is 0. Sine of pi over 2 is 1 times negative 2 is 2. So the next point is 0, negative 2. Right? And we could keep going. But I think we have our orientation. Our orientation goes this way. So it's going to come around. So we have that. Okay. They want us to find the point of tangency at b equals 3 pi over 4. So let's do that. So that was 1. Let's do 2 now. To find a tangent, a point of tangency, we just need to plug it in. For b is 3 pi over 4. This is going to be our t in this case. They just gave another letter for it. So r of 3 pi over 4 is equal to, okay, 3 pi over 4 of cosine is radical 2 over 2, so I get 3 radical 2 over 2. Same thing for, and actually this cosine is going to come out as a negative, because it's to 3 pi over 4 is to the left. Sine of 3 pi over 2 is going to be radical 2 over 2 times that negative 2, so I get negative rad 2. Okay, so we are graphing that. That doesn't give me a point of tangency, but it does point at the point of tangency. So the point of tangency is negative 3 rad 2 over 2, and then rad 2. Okay, and it is going to be, does that end up being a positive? No, I don't think so. Let me double check this. 3 pi over 4 for cosine is a negative. Rad 2 over 2 times that is 3. Sine of that is a positive, but times the negative gets a negative. Yeah. So we are some point down here. I'm just going to put a big dot there. Okay. We found point of tangency. The next thing they want was the tangent line at that point. So I need to find r prime. So looking at my function up here, 3 cosine, derivative of cosine is negative sine. Derivative of sine is cosine, so negative 2 cosine. And they want the tangent vector at that value. So r prime of 3 pi over 4. So we get sine of 3 pi over 4 is a positive, so negative 3 rad 2 over 2, comma, and then this is going to be a negative, and so we get rad 2. Cosine is rad 2 over 2, negative. The 2's cancel, negatives cancel, leaving me a positive. So as you can see, this tangent vector, I'm going to do this in blue here. If I start here at this point, and I go down negative and a positive, the x is negative direction and then positive, we get a point of tangency that looks like that, right? It's negative to the left, some negative, and then some positive up. So it explains the direction that our orientation is moving. If it's going clockwise like that, the tangent line would be directly moving out that way. Okay, so that is how you find a point of tangency. Plotting your vector. I didn't need perfect on the sketch. I just needed some kind of idea so I can see the points down there, and then that the tangent vector actually makes sense on the graph. It's pointing in the direction of movement. The way it's coming off the circle makes sense as well. So there we go. All right, let's try another one, but we're just going to do one thing here. Let's find the tangent vector. I'm actually going to sketch again, even though I said I'm going to do one thing. We're just only required to do one thing, but I do want to see it on a graph. So if I take my graph and I set them I figure out each component, x of t equals 5 e to the negative t squared, and y of t equals e to the negative t. I think, what could we do? So this is equal to 5 e to the negative t, and then this is raised to the t power. Remember, when I have a power raised to a power, I multiply. So if I take that, that's x equals 5 times e to the negative t to the t, and then I can replace now x equals 5 y to the t. All right? And then if I change forms here, I have x over 5 equals y to the t, and we can switch this to a logarithm. So this is the log of base y of x over 5. So we have some kind of logarithm function. It's really extremely gross. So maybe let's go find GeoGebra. Let's go graph it in GeoGebra. If I can get there on my iPad. All right, so we just need a 2 space. Oh, maybe go. Well, of course it's updating. Okay, we'll wait through that. Forgive me for spending video time on that. I just don't want to start my video over. Okay, so let's answer the problem and then we'll look back at it. Let's do that so I don't waste your time. Okay, so I could do some kind of replacement like that. Sometimes that works out really nice and pretty. In this case, it really didn't help me much. It felt more difficult than it was worth, really. So let's go ahead and just find the tangent vector, and then we'll look at the graph as soon as it's done downloading. So r prime of t, all I got to do is find the derivative of each. This one is a bit tricky because it is a chain rule. So chain rule, I just get the same thing. So I know I'm going to have the same thing, but I get the derivative of the inside of my power, which is negative 2t. So I'm going to have a negative 10t e to the negative t squared. And then derivative of e to the t is e to the t, but the chain rule gets me a negative. So there is my tangent vector, and they just want to know, what is it at 0? Okay, well, I get 0 in my x, and then I get a -1 in my y. So let's take a look at the graph, and we'll try to make sense of this to make sure it makes sense with the tangency stuff. So my two-dimensional grapher, there we go. All right, we're going to graph, what did we get, x or t really? Let's see if we can relate it again. I'm thinking that we can. Does this give me vectors? Doesn't look like it's going to give me a vector value function. Okay, let's go back to this and see, maybe is there another way we can relate? I'm trying to get rid of t. Okay, well, if I take this, I don't think this is going to get nice and pretty for us at all. So I changed my problem. My previous notes, I had that to be a nice pretty t. And when that's a nice pretty t, it does work out. So I would graph, I'm going to leave that to you, since I have found that my change I made it nastier than I wanted. If you would like to plug those in and look at it, what's very important here, what was asked was to find the tangent vector at that point, which is right there. The second part isn't part of the problem. I just wanted you guys to be able to see that if you graph them, that point, and you put this vector that I highlighted at that point, it makes sense. It looks like the tangent line. It describes the way the path is moving. So we'll leave that out. Sorry that I misled you there. If you can find a vector graphing thing, plug those in, take a look at it, and then move on with your life. I'm not going to have you sketch anything crazy like that to show me. I just wanted to point out that the tangent line makes sense with the tangent vector.